All right, so section 12(2) is lines tangent to a circle. So I can solve problems involving tangent lines. All right, so we have a couple of vocabulary. I'm going to do the second vocabulary first. Tangent to a circle is a line that intersects a circle in exactly one point. So the only time it touches the circle is at one location. So it's not like a diameter where it intersects twice. If we have a circle, a line that is just going to intersect one time is a tangent line. So the point of tangency is the point where the tangent line intersects. Okay, so here we go. Here's the theorem. If we have a line AB, so if line AB is tangent to circle, now that's a symbol for circle, and then the center is how we name it. So it's tangent to circle C at point P. Then line AB is perpendicular to the radius. So if we're using this picture here, P, the tangent point of tangency, the radius is CP. Okay, so if AB is a tangent line, we know that it is going to intersect the radius at 90 degrees. And then vice versa. If AB is perpendicular, there's a symbol for perpendicular, to the radius, then AB can be defined as, so is a tangent line to circle C. All right, so in this case, if I don't know that it's tangent, but I know that this line is perpendicular to a radius, that means it has to be defined as a tangent line. All right, so we're going to use this information to solve problems. So is KJ tangent to circle P at J? So I'm asking, is this 90 degrees? Well, what theorem is satisfied if that's a 90-degree angle? Well, if that's a 90-degree angle, this becomes a right triangle. Okay, so we're asking the question, okay, now where would the hypotenuse be? It would be all the way out here. So is this hypotenuse, KP, okay, is that, so if that's 10, so is 10 squared equal to 6 squared plus 9 squared? This is the question we're asking, because if this statement is true, then this is 90 degrees. So we have 100 equal to, remember this is a big question mark, is it equal to 36 plus 81? Is 100 equal to 117? The answer is no. Okay, so is that 90 degrees? No, so it's not a tangent line. All right, so now the other type of problem you'll see is this time they say ST is tangent to circle R, so it is intersecting at one point. What is the radius of the circle? Okay. Now this problem is going to be set up pretty tricky, okay? So this is 90 degrees. All right. So if we're solving for x, Now, the radius or the hypotenuse over here is a total of x plus 18. Okay, because from here to here is 18, from here to here is x. So we're going to plug it in. X plus 18 squared is equal to x squared plus 24 squared. Now, how do we square this? Well, we're going to have to, and we're going to actually review this from algebra after this chapter, but x squared plus 576. Now we use the FOIL method, x squared plus 18x plus 18x plus 18 times 18 is 324 equal to x squared plus 576. Okay, so this is really x squared plus 36x plus 324 equals x squared plus 576. Now we're going to solve for x. So the first thing, I see 1x squared over here. If I was to try and combine these, they would cancel out. So what we're left with is 36x plus 324 is equal to 576. We solve 576 minus 324. 36x equals 252 divided by 36. X is equal to 7. So the radius of this circle is 7. All right, so that's a pretty tricky problem here. The other type of problem you'll see, line M is tangent, to circle T. Okay, so line M, this is tangent to circle T at this B. So that means both sides of these are 90 degrees. Line N is tangent to circle C circle T at C. So this is 90. What is the value of X? Well, now we're dealing with angles. Okay, we're trying to find the measure of this angle. Well, the first thing, what is this shape here? Because I know 1, 2, 3 out of 4 angles in that shape. Well, it's a quadrilateral. So some of us remember that quadrilaterals add up to 360. If you don't remember, you can do 4 minus 2 times 180. Tells me that those will all add up to 360 degrees. So therefore, 360 minus these 3 angle measures, so minus 90, minus 135, minus 90, leaves me with 45 degrees. So X equals 45 degrees. All right, so we can do the try it problem on our own here. So they're asking, is MP tangent to this circle here? Okay, well, I know that this angle here is 58. I know that this is 33. I'm trying to figure out, is this 90? Well, this triangle here, we do 180 minus the 2 angles that we know. Oops, this is 33. Minus 58 equals 89 degrees. Is 89 90? No, so this is not a tangent. All right, so now this time we're going to skip this problem. Don't worry about it. All right, the last type of example says, segments that are tangent to a circle theorem. Okay. So this says, if AB and AC are tangents and they meet at an exterior point, then they are congruent. So what does this mean? So since AB and AC are tangent to the same circle and they share point A, then this is going to be congruent to this. Okay, so they want us to use this situation over here. What is the perimeter of all of these added together? So first, this point, exterior point, is made up of this tangent and this tangent. So you're looking at the distance from the exterior point to the point of tangency. If the distance from here to here is 7, then the distance from here to here is 7. Okay, over at point B, we know the distance from here to its tangent point is 2, so this one has to be 2. C to the point of tangency is 3, so C to the other point of tangency is 3. D to this point of tangency is 6, so this one is 6. Now when we find the perimeter, we have to add up all of these pieces. So we'll start over here. We have 7 plus 2 plus 2 plus 3 plus 3 plus 6 plus 6 plus 7. I went all the way around, equals 36. And that is it.